All right. How you doing,
Very
man?
good, very good.
Hey, dude.
Where have you been?
What happened to April?
You were out.
Sorry about that. I was out.
It's your fault.
It's my fault.
Okay,
Sorry
good.
about that. We missed another month.
Okay, that's okay.
That's how it rolls, man.
We'll get it better.
Cool. So what have you been up to?
Well, we're fixing a lot of bugs,
Okay.
adding a bunch of features. I also want to shout out, for Milan, the progress we made there.
Tom Kirby Green, here you
Yes.
go.
Yeah, he was asking. Oh, I have my cheat sheet.
Okay, let's see it.
check. We bunch, all of you guys. I had to say thanks because 100 bugs, a lot of downloads of Milan, like around 20,000, and 16 plus 5,400 forever.
Okay.
And we have the compiler on riseforfun.com/VCPP.
Yes.
Go
Okay.
try it out. So you can just type your code and it compiles, and you
Nice.
see the errors. And there was one funny error we want to, give a shout out for, whoever
Did
it
it
is.
involve auto by any chance?
Yeah, there was auto v equal just angle bracket and
Blank angle brackets.
yeah,
Huh.
and it just didn't work. So we fixed that. It works now. Sorry about that.
So we
Little
broke
bit.
auto, Herb. Herb always talks about everyone should use auto all the time.
Yes.
Nice. So it doesn't work in that case, but now
That's
it does.
good. Yes, yes.
That's a cute bug. Right
More
on, man.
feedback. Try it out on the web. Download it, whatever you want.
Cool. So hey, listen. Today we're going to learn about NuGet.
Good. Yes, exactly right. NuGet, NuGet, the guys that are working on NuGet outside of Microsoft, they added support for native code.
Great.
And we're gonna learn more about what's done, what's there. I'm really passionate about this. I really come from the libraries team. I think libraries are one of the most productive things you can add. You need a library, just go get it, right? And give us feedback. What do you like about what you're gonna see now? How do you package your library? How do you want your libraries to, come into your project? Let us know. Let us know. It's really something I really want to spend some time next year. So every feedback you have, send it my way, send it Charles' way, and this should be a good, startup.
Right on. Well, hey, let's go learn a lot about NuGet. And it's great that it's available for C++ devs now. All right. So we are in C++ world with Garrett Serack.
Yes.
Is that how you pronounce your name?
Close.
Close. Thanks for coming on Channel 9 for an episode of Going Native. As we discussed in the CTOR constructor, you have done an implementation where now NuGet support is available for Visual C++ developers.
Absolutely.
So the reason that it took as long as it did, is it because it was a complicated problem to solve? And what were the complications?
Well, so NuGet for C++ or NuGet for managed code, for .NET libraries and stuff like that, was not terribly complex. There's only so many different ways you can make a .NET library in the first place, and then even then .NET libraries have their all the metadata is contained in the same file as the linker library, as is the shared library itself, and everything is encapsulated in the assembly, which makes it really easy. And they're really easy to figure out. Well, where does this thing go for? Who does it for? What version of the framework is it for? So that's great and easy. Now, C++, of course, what do we have? We have lib files, DLL files for redistribution. We have header files. We have some documentation. And then people do things with a great deal of different ways. They put, some people want to have just one library and you link with that, and it's going to be shared library, so that you link with the library and they provide you the DLL. But some people say, oh, here's a release version, here's a debug version in case you need to do that. You might need to have symbols around for that. Here's the header files. Oh, but we want the header files in a subdirectory. Some libraries want it so when you go include and then OpenSSL/ and then the file name. Some just want to say include whatever. And we have to make sure that the include directory gets properly added. We need to make sure that all of these, the linker library gets done. Some things have to define some symbols, so we need to have, has this library, installed and stuff like that.
Understood.
And so the complexity of C++ is much, much larger just because of the complete and total open-ended variations you can face. And then when we started actually looking at the ability to build these libraries, we started saying, okay, well, so how do we want to put these in there? Do we want to mimic the way that .NET does it so that you put these things in separate folders or things like that inside the NuGet package file itself? Or do we have to have some intelligence in there or what? And originally we tried we tried to look at a couple of different ways to shoehorn this in there. Visual Studio 2012 came with the extension SDK model, which allows you to basically take and build your libraries and then put them in a particular pattern and put the file names in the right places in the right stuff, and it does the right thing most of the time. But it turns out to kind of take that model and implement it inside of NuGet was really going to be a big nightmare. And then there were so many unanswered questions like, well, what happens when this, when the platform version gets incremented? Are we going to be able to use a Windows 8 library on a Windows 8.1 platform, and vice versa, and things like that? And it just started getting more and more confusing as to how that's going to work. And we actually had one of our community members, Eric Schultz, who works in the community. He actually implemented a prototype for this.
Okay.
And he shared his branch on Codeplex, and we looked at it, and this whole conversation got tossed around, and eventually we said, yeah, we can't possibly do that. And Eric was the one who was like, we can't possibly do this. He says, here's my branch, and here's exactly why we don't want to do this, which was really kind of funny, because he did all this work that he says, we can't do it this way. Okay, so let's take a step back and figure out another way we can do this. And do we want to just minimally support stuff? And the more we started looking at how we wanted to actually build these things, we thought, well, let's try and keep the changes to NuGet as simple as possible. And the biggest thing we needed to make sure happened was our ability to, say, insert a Visual Studio targets file, an MS Build file, essentially, into the project, which was actually an outstanding request from the Manage people for so long. It's one of the features that they desperately wanted anyway, was to be able to include a targets file that got included into the project. And so the NuGet guys said, sure, we can do that. That one's easy. We'll knock that off. And so they did. And so then all we had to do was provide a targets file inside of inside the package that knew what to do with all the stuff you needed.
Okay.
And that's where it got really complex, because we started looking at all the different ways you could look at libraries, what we call pivots or configuration choices. And Visual Studio exposes a couple of simplistic configuration choices to you off the top, which is release debug, which is your configuration, and your platform, which is, x86, x64, actually Win32 in C++. It's called Win32, x64, and ARM.
Okay.
And the problem with that is that really doesn't express all the different options, right? Because we also have linkage, right? Do I want to dynamically link to this? Do I want to statically link to this? We have, what kind of calling convention would you like? Oh, cdecl, standard call, something else. This gets worse. What kind of application are you targeting? Is this going to be a WinRT app? Is this going to be a desktop app? Is this going to be and there are quite a few variations in there, like drivers or utilities for drivers. I mean, it's funny how you start digging into this and like, oh my goodness, this is getting very, very complex already. And then, so then you start multiplying all of these different combinations out. And right off the top of our head, we could come up with 3,072 combinations was our first cut. And it's like, how the heck are we ever going to support something that can have any number of these variations? Not necessarily all, obviously, because we're never going to, those get a little large. But we need to be able to support all of these, we need to be able to support whatever the developer wanted to do. And we need to do it without having somebody to actually write this code by hand. And that's what we did here. I've got an example up here where we've got this targets file.
Okay.
And this is something that we ended up generating. And it's got properties, item definition groups, and all this MS Build stuff in here. And it's, when you do this sort of thing, it's terribly complex. And one little problem where you leave out a bracket or a brace or something like that, and it doesn't work. And it's like, okay, well, why? Why did that not work? And then when you've got the more conditions you add to this stuff, it just becomes very brittle. So we obviously said we didn't want people to just have to build everything by hand. I mean, that would have been the easiest, because then, oh, we're done. Visual C++ support, build your own targets files, have a nice day. And so what we did is we actually came up with a language that was much, much simpler, that would essentially generate out all of these different variations of the MS Build script for you. And generate all of these condition statements and all this stuff that was much, that just basically eliminated all the confusion.
Excellent. Now let's step back just a little bit, because there's a lot of old school developers out there. You know that. You're a C++ developer. I mean, you've probably been doing it for a while. NuGet is sort of, I wouldn't say it's a new shiny thing, but it's a different thing. And so why don't you really briefly tell us, in some sense, what's the obvious benefit of using NuGet? I mean, do I get automatic updating services? Do I get, so if I want to download libraries via NuGet, I can say, well, hey, is there some way that makes it easy for me to find the libraries in the first place, then install them, then they automatically update? A header file changes in my package. I have to download a new package, or does the header file come back down?
Okay, so
these are my questions.
So NuGet, of course, is a package management. Well, it's a package management system for SDKs and libraries.
Great.
It takes these things and puts them in a way that's both discoverable and easy to use.
Okay.
Right? And so we want to make sure that you didn't have to understand the package format in order to actually consume these types of things, which is important. And then, of course, discovery, which is making it easy to find and rely on these things in a convenient manner.
Okay.
So NuGet provides the ability to package all this stuff up for Visual Studio or for .NET libraries and managed libraries. And then when we added the C++ stuff, what it does is it is the NuGet plugin for Visual Studio, which ships in 2012 already.
Okay.
When you say, I need a library, and you go looking for it, you can type in your search criteria. And searching is admittedly, I think, a little simple at this point in time, but at least you can say, I need OpenSSL. You type in OpenSSL, you hit search, and it'll show you up the library for OpenSSL,
Great.
which is awesome. You hit install that, and you're done. Your linker libraries are all hooked up. Your include files or your include directories are all hooked up. Any additional compiler defines are hooked up, and all automatically. You didn't have to touch nothing, didn't have to edit anything, didn't even have to go into your properties menu and select that stuff.
Wow.
It's already done for you.
Nice.
Which completely makes this a frictionless use. When that package gets updated, you can go back into the package manager window in Visual Studio and say, show me the updates for any packages I've got installed for this project. And boom, you'll see the update. And you go, oh, install that. And so it removes the old one, puts the new one in there, and you're done.
Okay.
And so NuGet packages are coarse-grained in that regard, is that it's either, take this one out, put this one in.
Versus if like dx.h is part of a package.
Yeah.
I mean, so something like dx.h, it's just a header file.
It's
right?
just a header file.
And it's a relatively large header file, but super useful. And so if I'm a developer and I want to go, hey, I keep hearing about all this DirectX stuff. Let me go get this dx thing, dx.h thing. Now, I guess you could say, well, then why would you put it in NuGet? My answer would be because of what you just said, discoverability and install all
and ease of use for installation.
So rock and roll, man.
Yeah, absolutely. So when you do that, so when we got these things in there, and a library can be something just as simple as a header file. There are a few open source projects which are just a header file or two, which is great. That makes it really easy because let's face it, no linker libraries, no DLLs, no redistributables. Hey, that's great. But the same thing has to work for that as it does for the very large solution.
Absolutely.
And even better is that now each library can take a dependency on whatever things it depends on. So OpenSSL is a great example. OpenSSL powers the secure sockets layer of just about everything in the open source world. And it has a dependency on zlib, which handles compression and whatnot because it needs that for the communication.
Okay.
So now we have our OpenSSL package, which doesn't actually include any of the zlib stuff. It has a reference to the stuff for the zlib, so that when you install OpenSSL, it will install the redistributable components from zlib all automatically, and you didn't have to do anything there.
Great.
And so the DLLs that you need, that OpenSSL needs at runtime, actually are also pulled from the redistributable component from zlib and copied to your output directory. So when you go to run, it's all there.
That's really, really, really excellent because a lot of times one of the productivity missteps in C++, even in the best tools in the world, is this notion of, oh man, I forgot to add this reference. Or yeah, that's not quite the header file I needed. Oh no, that's right, it doesn't live in that directory. Or blah, blah, blah. So this is beautiful to hear. It's a beautiful productivity story. One question I have for you. One of the good problems C++ has, or maybe it's a bad problem, is that there's multiple libraries to do the same thing. So if I want an XML parser, what XML parser do I use? So if I use your tool and I say XML parser, there's any number of XML parsers you can use out there. Do you have some sort of system where, a group of people will pick, this is the one that we think would be a great NuGet package we'd like people to use, it's the most modern, it's blah, blah, blah. That's really my question. So are you just going to give me a random list of a bunch of...
So APIs are the greatest thing about APIs is that there's so many to choose from. Right? And unfortunately, a lot of the times, you might say, oh, I need to use this API here. Well, and that needs to use an XML parser, and it's already chosen to use this one. So really, we have to have the ability to have all of them there. And as the developer or the consumer developer, you need to be able to choose the one that fits your particular needs. You might like one particular version over another. There's actually another SSL library. I don't even remember what it is. But there's actually two out in the universe. There's OpenSSL, and then there's this other one that nobody uses.
Okay.
And for some reason, somebody might want to say, oh, no, I want to use that one. But this happens a lot. In compression libraries and stuff like that, you'll find the same thing implemented in another way. And unfortunately, there's no possible way that we can just say, oh, we're going to support this one. We have to support everything, or have the ability to support everything. So somebody can produce a library that says, oh, here's your zlib, here's, my version of zlib or something like that, and you can actually have multiple of these. And then, of course, that makes discovery a little bit trickier when you have, 3 or 4 or 5 of a particular thing out there. But in the open source world, and especially in the native world, people know their libraries. I mean, they know what they're looking for. When I need a particular library, I know what it is I'm looking for.
Right on.
It's really not that complicated. I think actually .NET is a lot more tricky in this regard because it's so easy to crank out a library. It's like, oh, I made a library that does X, Y, Z. Yeah, there's 4 others that already do that. Like, look for logging or stuff like that. It's like, there's logging stuff built into the framework.
Yeah.
Why did you need a library? And then, it's like, oh no, but I wanted to add these features on top of the library. And I've done this myself. I have a whole stack of assemblies that I build of libraries for building my tools because I want these features, that features, and then I want this and that. And the great part is now is I used to actually have to drag in stuff from a whole bunch of other projects and kind of, here's my big project here. And now I can just rely on those. So our own tools get to rely on that kind of technology now too.
Excellent. So now how long, you've been at Microsoft now for 7 years. And I know people on Channel 9 have seen you before. You did this really interesting open source talk. I can't remember exactly.
Called Co-op.
Yes,
Yeah.
Co-op, man. And
so,
you had the cool whiteboard metaphor. That was good stuff.
Yeah, and so what we've got, so the tools that we worked on to make these packages are actually part of our Co-op project.
Okay.
Because what we were actually in the process of building this package management system for Windows in general. And one of the things we need to be able to do is build better and reliable ways of building great open source libraries that everybody could consume, and these things would be very common rather than having everybody do this one off. And last summer we released our first version of Co-op, and it was great and it worked fine, all that. But then there was Co-op, and then there was NuGet. And Co-op had some developer libraries, and NuGet supported developer libraries. NuGet only supported .NET, Co-op supported .NET and C++, but it wasn't the same, and it certainly wasn't the same as that. And our .NET libraries weren't near as good as the way their .NET libraries worked. It was like, well, hang on a second here. So last fall I stopped and said, okay, we're just going to stop development here. We're going to stop and think about this very clearly. Right? What do we want to do? How do we want to make sure that everybody's working in the same ecosystem as opposed to building silos of, no, my package is better than your package.
That's what boys do, man.
Which is what boys do. And I tell you, it was funny because I came in one day and I was so frustrated. I'm like, it just makes me mad when there was this thing and I was already working on that. And I'm like, hang on a second here. What if I turn the tables on this side? It's like, what if I tried to give away every scenario I wanted to? I wanted to give away my development scenario. I don't want to have to worry about that anymore. Because my ultimate goal wasn't to build a package management system. It was to build better software for Windows. So I'm like, okay, if I gave away my scenario, then it's their problem. Oh, I like that. So I started talking with the NuGet guys, and I said, well, so what is it going to take to make C++ happen? They're like, they're not C++ people. They will tell you that the first time you walk in the room, they're like, so we don't know nothing about C++. We don't want to know nothing about C++. And so if you want to do all the work, then we're happy to take it. Oh, great. That's just awesome.
Oh, man. And
so we started talking with them, and then started talking with people in Visual C++ and said, well, what are you guys thinking about and whatnot? And so that's where we found out about things like the extension SDK. And so we took a good look at that and said, we can try to make this work. Let's see what we can do. So I want to make sure that everybody want to be on board with this so that we were making one better ultimate way of making it all work.
Cool.
And so after getting a bit of consensus, that we all want to put our efforts into making NuGet the way this works, regardless of what kind of libraries you use or what kind of managed or non-managed code you use, one way. Okay, great. So now what? Well, now we need to build the tools. Okay, so we've got the NuGet guys went off and started adding a couple of features we needed in NuGet. Great. And then we sat down and said, okay, well, how do we want to do this? And taking into the all this effort that I've spent in the last few years trying to figure out how to build packages for C++, and now adapting our model to fit specifically NuGet, we came out with our Co-op tools, our Co-op PowerShell tools for NuGet, which allows us to generate these packages from a very simple script that generates all this complexity, manages all the files for you, and sticks it all and says, here's your files. And all you have to do is provide the stuff and say, when this condition is present, here's what you want to use.
But let's talk about that. So I know that there's people watching this video that create their own libraries and probably would love to jump onto this bandwagon. What does an author of a library need to do to prepare his or her package?
So
from a manual perspective.
From a manual perspective. So you need to be able to build your binaries, obviously.
Well,
Well, so somebody said, can you just build all my binaries? Like,
come on, man.
That's a little bit of, gotta do a little bit of work here.
Yeah.
So, and actually we are doing work to make the automation of building all the different variants very trivial as well.
Okay.
So basically making it so that you can batch build all of the different varieties of a particular set of library against all the different tool sets and all the different platforms and whatnot that you want, so that all you have to do is define this once and you can say, do it all for everything all the time, in parallel, which is coming soon. But basically, as long as you can build your libraries and you can point to where the files are going to be, all you have to do is basically say, here are my header files, and here are my library files, and here are my my DLLs, and you can say this set here applies to just this condition, where it's debug in x64, debug x64 in desktop, or x64 desktop and release, or whatever combination of those things you care about. And if you only have one version and you say, here's my files, for when you're using x64, this is the one you get, it's the only one you get, too bad. However they want to package this up, all they have to do is be able to specify which files go in which bucket, essentially. And we handle everything else. And you don't have to say, there's no complicated, we actually have a, I don't know if we can even see this on here. Here's a good example of this. So
Here, let me go ahead and zoom in so that people can see this.
I'll zoom in a bit farther. And I did up a demo on, I think it's on YouTube right now, about how to actually do this. And it's fairly straightforward.
Okay.
And a few of the community people just jumped on this and started cranking out a few of these packages. So it works fairly well. It's a complicated subject. But
so this is what we're looking at right now.
This is the script that we actually generate the whole package from. So given just one single script, you can actually say, and so there's a bunch of metadata in there that's basically just the stuff that NuSpec requires, which is, what's the name of the package, what's the version, what's the title, who built it, that sort of thing. Where does this stuff come from, blah, 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 blah. And then essentially all you have to be able to do is say what files go where. And so we have a file section, and you say, oh, here's the include files. It's this, 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 and this. And you can have wildcards and stuff like that. And you can have, and then you can say, well, you have under a different bunch of conditions, we want to be able to do a few different things. Let me actually find, where's my, so here so here's a good example. This is probably not looking so easy to see right now. But basically we have the ability to say, let me just format this a little easier so you can see what it is we're doing. So in this particular case, he's got stuff that goes into the targets file.
Okay.
And he says, oh, for x86, for the v110, which is VC11, static cdecl release, I want to add this to the defines and this to the includes. And that's all we have to do. So say add this here and add that there.
Okay.
And then we hit the button, and it cranks out the file. And we tried to make it that simple. And what's really funny is that behind the scenes, this actually generates an MS Build project file.
Nice.
So we have this whole thing that basically translates this stuff in MS Build, and our internal model is actually using MS Build. It just, you can't tell because we made it really simplistic. So what we've really done is put a really simple, thin wrapper around MS Build that makes this really trivial to express things. Because the way that MS Build is very literal. Like, here's my XML, here's this node in here, and you have to express this out in a very specific terms. And here what we try to do is keep the grammar so simple that anybody can do this.
Great. Now what about C libraries? Should be the same, right?
C is exactly the same thing.
Right on.
No difference whatsoever in this regard.
So, and the other question I would ask is, this is targeted towards our compiler, our stack. What if I'm a Clang, like Clang is what I use to blah, 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 and I don't use our tool set. But you know what? It's C++. It shouldn't matter. I'm building standard library, a library that's basically portable.
Right. So
how does that work on a different tool chain?
So a different tool chain, there is no problem using a different compiler with this. The difference is that the work that we do to generate the MS Build script is good for MS Build. So unless you're using MS Build, that file isn't going to be a lot of help. However, that being the case, the packages we generate, when they stick their binaries and all their files in a particular way, is a very predictable format for how things are laid out. So even if you wanted to manually consume this, let's say I'm a big fan of, NMake, and I built my project scripts in NMake, so I don't use Visual Studio and I don't use MS Build. Well, you could still use the NuGet command line to install the package to the local directory, and then say, add this particular directory, because it's easy enough to find to my includes, and add this particular output as things I need for libraries and things like that. It's not terribly difficult to replicate that for yourself. One of the things that we're actually looking at doing is also including in the future, so when we build our packages, is it generates a script for CMake, as well as the targets file, because the information is the same. We know what information you're looking for. We've already got it in a model that we can manipulate. It shouldn't be terribly difficult to actually say, let's submit a little CMake script, so that when you install this into a directory that has CMake, you add one line to your project, your CMake project, and you're done. And it would work the same.
Excellent.
That's going to take a little bit more work, but I don't think it's all that tricky. I think it's just a matter of will to make that happen.
Cool. So let me ask. I mean, this is early days here. What are some of the things you're working on? What's some of the feedback you've gotten from the community at this point?
Well, like all things C++, people are, they put their toes in the water slowly at first before they jump in. Because changing the way you work, and our biggest thing is we didn't want to change too much about the way you work. Right? If you've got things laid out in a certain way, I want to be able to keep that as easy as possible for you. A few people in the community have come back and they've started using this stuff, and they'll post questions either on our
Great.
repo on GitHub, or they'll post them on a variety of places. We have a Jabber page, we have an IRC
IRC?
site. Oh yeah,
Old school.
very
man.
old school. We have to,
Is that actually active?
Oh yeah, we have
Wow.
people on our IRC channel all the time. And variety of places, and even on the website where I posted the tools and whatnot, I put my email address. So if you have a problem, you can email me directly. Even if you don't want to go to the other places, heck, email me directly. I will find the ability to help you out with packaging stuff, because it's not trivial. There are lots of little places you can still get caught. I would not even and our tools are going to be in beta for the next decade, as far as I'm concerned, because there's just so much complexity that, I'm sorry, nothing's going to be perfect in this regard. And really, that's why I think nobody's tackled this up to this point in time, because it's just that hard. So we're going to have this continual feedback system where I put out builds, sometimes 4 or 5 builds a day. Sometimes take me 2 or 3 days to come, not grind through a bug and fix that up for the next build or whatever. But we're trying to make sure that we've got this steady flow of updates for the tools, because that's really what we have to keep doing is moving them along.
Yeah, and C++ needs to simplify itself a little bit as well, and that's one of these days maybe that'll happen. But
No chance.
no chance.
No way.
Come on, Herb and Bjarna, man. But I understand. I mean, clearly there's a lot of complexity, and that's just, and it stems from C, right?
Well, it stems from C. Well, C++.
Well, C++ just added more.
Well, and it's funny, we're dealing with decades of choices made by somebody else that were things. Like one of the things we ran into right after I did the first release of the tools.
Right on.
The day after that, we started working with some people in the community. I had a whole bunch of people on IRC. I actually had them on Link, and we were doing a big, this big hacking event. And one of the things that popped up was like, well, wait a minute, if I have zlib, or if I have OpenSSL, and it links with zlib, so it requires zlib, and that version of zlib was built with which version of the C runtime library? Because it turns out the Visual Studio, the C runtime library, depending whether you build with the static or the dynamic, or whether you build with the release or the debug, they have some different imports that are not present in other variations. Which is like, wait a minute, what? So I can't even choose that at the last moment. This is a decision that has to be made so early on. And this just, of course, is a nightmare, because, well, if that guy chose something, I now have to choose what he's choosing. So we can either try to make it so we can support as many options as possible, or we have to say, if this thing is a DLL, and this thing in here is a DLL, relying on that DLL, when you do it, you're going to be using the DLL version of the runtime library. And it's stuff like that that was very, it just blew our mind, when it's like, how can we make this even more difficult? Yeah. And that's that's the complexity we're dealing with. And these decisions, the decision on how some of those things were made, was done 15, 16 years ago. Because it was done. I can remember this. I remember the same problem back in the VC6 days.
Okay.
And so I was like, well, it's been there as long as that, and people just live with this. And C++ developers, the side effect that I think we've seen with this is that stuff becomes brittle and very superstitious in builds. And it was like this when I came to Microsoft. Somebody said, okay, if you read some of the documents, especially in some of the teams, they say, here's how you set up your machine so you can build our stuff. It's like, well, wait a minute. And this step 4 says I got to jump up and down while I'm installing the Office toolkit. Why is that? Why do I have to do that? Well, that's what the guy who got it to work did, and so we all do it exactly the same. And it's like, oh my goodness, we don't want to go that way.
Well, hey, I mean, look, that's one of the things that I think in the modern world, a tool like C++ and the tool chain all the way down the rabbit hole, I remember just about, I would say even 5 years ago, for example, the notion of a compiler taking care of automatic parallelization and vectorization was preposterous. That would be so complex.
Oh, yeah.
How could we ever figure out what actually could be parallelized on your behalf or vectorized on your behalf? It's an easier problem versus the parallelized. But that said, look today. Look today,
It's a
man.
walk in the park.
Yeah, and and we really have become, like, when you use Visual Studio, it's a compiler farm. It's a garden of compilers. Front end all the way through the back end, optimization, blah, blah, blah. And to me, it's like, as you say this, you're learning the very hard way how complex all this stuff is, because you have to package it up into some sensible package that I then get the benefit from as a developer.
Yeah, and the complexity with some of that, like the PGO, the profile guided optimization, right, requires you having link time compiler generation turned on when I compile the first library. So in order to make that and get all these benefits down the chain, I have to have variants of all those libraries compiled in that model too. I mean, we started building libraries, and we thought, oh, things like zlib, oh, they'd be like, 4 or 5 megs on the outside. Well, I think our zlib library turned out to be 30, and we don't even support all, and that's for VC10, VC11, and release debug, static and dynamic, and on x86, CDECO and standard call, because historically somebody built a standard call version of the C++ or the C library for zlib. So I was like, wait a minute, that's 16 variations or 32 variations already, and it's like, oh man, and that was zlib. And then of course, OpenSL depends on zlib. Well, which version? What are you doing? And oh my God, so our OpenSL library, which we thought was going to be in the 10 megabyte range, I think works out to over 50 now.
Wow.
And, we're going to be in a lot of trouble if the thing that consumes the, the next thing starts, getting this thing. And that's exactly what we ran into.
Understood. Well, that's probably not going to change anytime soon, but thank you for, on behalf of people that are going to take advantage of this stuff, I mean, thank you, because it's going to be a productivity bump. One of the things about C++ is it's not a language designed for pure productivity if you compare it to, say, Java or C#. But that said, with each iteration, it's getting more productive, and this absolutely helps. Because libraries are what it's all about, in some sense.
It is. Well, that's where all the productivity in any language comes from. Is can I consume a library quickly and easily?
Boom.
Java set the stage for this a decade and a half ago.
Boom. Yeah. Import.
It said, hey, we're going to come up with here's a ton of libraries right off the top. You can just use them. Holy cow! I've changed everything. Oh my God! Yeah, awesome. So C++, of course, has had libraries. We've never made them easy to get and use and reuse. And get and reuse and use is the big thing, because hey, OpenSL has been out there for Windows forever. Oh yeah, it's been out there for 15 years, no problem. Yeah, you had to download it, compile it yourself, then make sure you packaged it right and got those outputs. And then when you got those, then you're like, okay, put that in my, you're just shaking when you're putting it into your other project, hoping that it's going to link at the end. And so by making it simple and just streamlining it, that's where we're hoping to get this reliable software out of there. And then as we, so now we've got a great build of OpenSL that you can just consume. Oh, that's easy. Great, now I can stop making mistakes, the same mistakes for you and you and you and you and you and you and 15 other guys. I don't need to have making the same mistakes. We can just get one guy to maintain this, and everybody benefits, right?
Awesome.
Sharing.
Hey man, sharing is caring.
Sharing is caring.
And
there you go.
Open source is wonderful, and it's great when communities of developers spend their personal time, because you're passionate about what you do.
Oh yeah, this is my fun time. This is my work time. I have the greatest job at Microsoft. I keep telling people, because I get to work on open source software all darn day, and I get to do what I want and how I want to do it, and they just keep paying me to make it happen. It's like, this is kind of awesome, actually. And I go home and it's like, I work on it in my spare time. Because why? Because it's so darn fun.
Awesome. Now, you mentioned to me before we started shooting the cameras, because I was joking around by how many monitors you have. It's a really interesting setup. You say you have even more at home.
Yeah, so this is my work environment at work. So
we're in Redmond in your office.
Yeah, this is my office in Redmond. I don't actually work in my office very often, because it's hard to work on only 6 monitors. And at home I've got 8 in a similar configuration, except I got 2 more in the corners there.
Okay.
And the productivity I get from all of that, because I mean, even in this thing here, I've got at least 2 Visual Studios open. I got Outlook, I got Twitter, and this, that, and the other thing. And because I've actually got so many active channels where I'm talking to people on, I have IRC and email and Skype and Link and Jabber. I was like, oh my, I have so many places that people can get a hold of me. And I've always thought, geez, it'd be really nice to have this unified, but it's just, it's not something that I'm going to go and spend much time trying to worry about. So I just have a lot of these things up and whatnot. And this helps me. I think I think Scott Hansman once said that you get 40% bump when you add a second monitor for productivity. I figure I've added 7 monitors. That's 280% extra productivity. I'm rocking it.
Well, rock and roll. Keep on being productive and busting out these excellent package managers, man.
And so, and the last thing I want to mention is that we're even getting inside Microsoft. Teams are going to start producing their libraries instead of extension SDKs or any other model. They're going to produce packages for NuGet.
Awesome.
And eventually, I think we're going to see everything from MFC all the way down, packaged as NuGet libraries. Because once it's consistent that way. Oh, I want to add add MFC. Oh, that's great. Oh, I want to add the C++ REST SDK, which we published on NuGet.org.
Casablanca.
Yeah, Casablanca. That was. And so actually, it was one of my test libraries. I grabbed that and I repackaged it up, and it took me like. It only took me about an hour to take that library, and I took the binaries, ripped them all apart, and just, built the package, boom, clicked it, done.
Nice.
Now, of course, in the process of doing that, I uncovered about a dozen bugs that I was fixing during the development of the tools. But
Okay. Well, hey, understood.
that's what was good. But I think that at this point in time, our target is to get, all C++ libraries are going to be, this is the way you're going to get them in the future on Visual Studio.
Awesome.
Except for Boost, because Boost scares the crap out of me.
Well, that would be like the ultimate challenge for you.
It's like somebody every time somebody brings up Boost, like, Boost's too scary. I can't do that one.
Sure. And you don't need to do it for the STL because it comes pre-installed.
Yeah.
On any version that we release. It's a standard library.
We have a version, but there's a lot of stuff. I mean, Boost is, the library to end all libraries.
Yes.
And I'm really kind of, I know we're going to get there one day, but I'm really kind of worried because the build alone for that thing would probably bring me to my knees.
Because of all of the
variations
forks and variations.
Oh, yeah.
Well, hey, man. You know what? Here's the thing, though. What if you could automate that? What if you could take advantage of the cloud and like 1,000 to maybe let's say 10,000 cores? Throw some AI over this. Have that figure out all the dependencies. A giant dependency graph.
So
a version graph. Okay.
We're actually building tools for that right now that'll be able to leverage stuff
Rock
like
and
that.
roll.
So our build automation tool is basically just, again, a thin veil on top of MS Build that we can say, given that project file, here are the 5 ways I want to pivot. I need to have different versions, release debug, these 3 platforms, desktop, Windows Phone, Windows RT. I need to have a pivot on debug release. I need to have a pivot for whatever and whatever. And some of these things can be anything you want. So one of the things that you can pivot on is, or you can add your own pivots. So like, oh, I want one for multi-byte character site, or I need it for, for Unicode or whatever. It's like anything you need to be able to do. And then say, for all of these things and then across the different tool sets. So I want VC9, VC10, VC11, VC12, or whatever. I need to have all these things. Oh, and I want to do CLang and GCC at the same time.
Yep.
Run that same build script. Okay. The trouble is that when you build that same thing, sometimes the output directories are set in the same spot. So what we need to do is actually fork that off and say, when we're doing it this way, capture those changes, these changes, and eventually we'll be able to make the packages by just looking at the outputs and say, well, here are the library files, and here are the DLLs, and that's the only thing that changes. And if you need the header files, done.
Great. Excellent,
So
man.
we're getting there.
Perfect. Great to meet you and talk to you, Garrett.
Hey, no problem.
Thanks for coming on C9 and keep on rocking
enjoyed
these
it.
great tools for C++ developers.
Thanks.
Cheers. All right. Well, that was fun to talk to Garrett again and
yeah.
spend some time. NuGet
Yeah,
is
it's
really
nice.
cool, man.
It's pretty cool, yeah. So don't forget though, feedback about what you like, you don't like about NuGet for C++, and what you use right now to package your library, what you use, what your friend use. Let us know, what you want to see, what you don't like to see, the usage. It's very important because I really want to spend some time there. So let me know, feedback, please.
Excellent, man. Well, hey, on that note, maybe we won't miss a month, huh?
Okay.
What do you think? Should we do it a month?
Yeah,
from now or what?
no. Let's do it.
Really?
No
June,
missing.
we got Tech Ed, we got
make
all kinds of things going on.
I'm gonna
man.
make it.
All
You
right.
can go on
Build.
vacation. No problem.
Right on, man. Well, hey, always great to see you.
Ciao, man.